Good morning, everyone. Hope you're doing well. Today we will start with the second part of Unit 3, Chapter 1. In the first part, we discussed that all chemical reactions involve a chemical change. Today we will discuss Lavoisier's law and energy exchange during a chemical reaction. At the end of this lesson, you will be able to differentiate between exothermic and endothermic reactions, identify energy exchange during a chemical reaction, state the law of conservation or Lavoisier's law of matter, and finally interpret a chemical reaction and write the word equation. Before we start, let's recall some concepts from the previous time. So as you know, any chemical reaction involves a chemical change where new substances are formed, and the identity of these substances changes. The original substances used are called the reactants. These reactants react with each other to produce the products, such as the example we took last time, where the reactants were vinegar and sodium bicarbonate, and the products were carbon dioxide, water, and sodium acetate. In the first part of the lesson, we mentioned that there are several signs which indicate that a chemical reaction is taking place, such as change in color, formation of precipitate, smell, release of a gas, and exchange of heat. During a chemical reaction, there is exchange of heat with the surrounding. A chemical reaction can produce heat energy, then it is called exothermic reaction, such as combustion reactions, example burning of wood. Or a chemical reaction can absorb heat energy, and it is called endothermic reaction, example decomposition reactions that involve the breaking down of a chemical. These reactions require heat to take place. In application 1, classify the following chemical reactions into exothermic or endothermic reactions. Don't forget to pause the video, then check your answers. So burning of a candle and combustion of fuel are both exothermic reactions because they produce heat energy. However, photosynthesis and decomposition of sugar are endothermic reactions because they need heat energy to take place. Some chemical reactions produce other forms of energy. In the following experiment, zinc and copper strips are connected to a lamp and placed in a lemon. Due to a chemical reaction, the lamp lights. Then electrical energy is produced. When a candle burns, light energy is produced along heat energy. So different forms of energy can be produced during a chemical reaction, such as electrical, light, and heat energy. The following experiment is performed to explore Lavoisier's law, who studied the variation of mass during a chemical reaction. Two reactants, calcium chloride and sodium sulfate, are placed together in a flask. As you can observe, the mass of these reactants is 184.34 grams. The contents of the flask are shaken and left to react. As a result, two new substances, sodium chloride and calcium sulfate, are formed. The flask is again placed on a balance. The mass of the products remains 184.34 grams. Therefore, Lavoisier stated that the mass or the amount of matter is conserved in a chemical reaction, which means that it doesn't change. So Lavoisier's law states that in a chemical reaction, matter is neither created nor destroyed. It is only changed or transformed. The mass of reactants and products is equal, thus it is conserved. In application 2, you're given that hydrogen and oxygen react to produce water. In part 1, you have to calculate the mass of water produced, while in part 2, you have to calculate the mass of oxygen used. Read the given carefully and don't forget that you have to apply Lavoisier's law and simple maths equations. So you start by stating Lavoisier's law. According to Lavoisier's law, matter is neither created nor destroyed. Mass is conserved. Then mass of reactants is equal to mass of products. In part 1, the mass of water, which is the product, is the sum of the mass of the two reactants. While in part 2, to calculate the mass of oxygen, that is one of the reactants, we subtract the mass of water and the mass of hydrogen. Each chemical reaction can be described by a word equation that shows the names of the reactants and the names of the products. Reactants are placed before the arrow, and the products are placed after the arrow. For example, During the combustion of butane gas used in stoves, butane and oxygen react with each other to produce carbon dioxide and water. This is the word equation of this reaction. Plus means and, while the arrow means produces or gives. In application 3, for each of the following reactions, write the word equation. Don't forget that the plus means and, while the arrow means produces or gives. Reactants are always placed before the arrow, and products are placed after the arrow. After studying the notes well and solving the application, please open your books to page 114 and solve exercises 2 and 4. Take care everybody and stay safe.